So the winner of the 2022 Turing Award is someone who won the award for the invention, standardization, and commercialization of Internet. The winner is R.Metcalfe. And because I have majored in computer networking myself, it is an honor to be able to give an explanation of his work. So there are many students here, and I think you may not be familiar with the name Robert Metcalfe, but and I also think maybe some of you know what Ethernet is, but for many people, do not know exactly what Ethernet is. So first of all, I would like to explain what Ethernet is. So briefly, to explain myself, I worked a lot in the area of communications. For my master's, I talked about LAN and ISDN, and I did work at GTE, AT&T, and Sprint as well. And one of my major papers has to do with measuring telecommunications. So this picture was made by Ethernet Alliance. It is an industry consortium of member organizations. It's a nonprofit organization dedicated to the advancement of Ethernet technologies. And so they're talking about how from automations to automotives and enterprises such as schools or companies and even service providers. Sometimes we call it the backbone network between the companies and even cloud providers. They all use Ethernet. So the font is a bit small, but so you may not be able to see. But on the bottom of the very right, you can see that the speed of Ethernet has increased by enormously over the past years. So if you look at the changes in Ethernet speed over the years, in the 1980s, it was about 10 megabytes per second Ethernet, and then it increased by about 10 times every 10 years. So it started to increase from 10 gigabits to 100 gigabits to 400 gigabits. So currently, we can enjoy the internet speed of about 400 gigabits. And there are continuing efforts to increase the speed of Ethernet to 1.6 terabits as well. So many people ask, is Ethernet and Internet the same thing? Because many people have heard of Internet, but not so much about Ethernet. So are the two different? So let's look into what that is. So Internet is used anywhere, and so Ethernet is the same. It's everywhere. So Ethernet is one of the technologies that compromise what Internet is. So the two are not the same. So the Internet, they're using several different technologies like wireless networks. That is what the Internet is. Ethernet is the core technology that leads to the Internet. So for example, I believe you may have these kinds of wireless routers. This is the wireless router at my home. So you can see that there is a cable connecting it to the wall. And even in my laboratory, you can find behind your desktop so many plugs. And so one of them is the Ethernet plug. And underneath the students' desks, you can also find hubs. And also, if you look at some expensive wireless routers, you can also find these kinds of connections. And you can also find a cable leading to the ground. But because we are, an engineering school, we have all of the lines hidden below the floor. So where do all these lines go? They go to the server room. So you can see that in the front, it all seems very clean. But actually, if you look at it from the back, there are so many cables connected. And this is all Ethernet. And you can see a lot of switches. So in all kinds of electronic rooms and wire rooms, you can see these kinds of switches. So this is a photo from 2 p.m. today. So it's very new. And so the cables and the technologies, this is all what Ethernet compromises of. So you may have seen these kinds of data centers. This is the data center of Google. And again, if you look at the data center from behind, you can see so many Ethernet cables. So going back to the image, even even in cars, the Ethernet is used, and for cloud services, it is used as well. For service providers, they are the people like SK Broadband or LGU Plus in Korea. You use Giga Internet at home, right? So, and if you look at the internet, you can see the wireless router is all connected to some cables, and the cables all link to the switches in the basement of the building. So the major telephone companies, such as Kuro, they also are connected to Ethernet. To explain Ethernet, we need to first of all go over some of the basics. So Ethernet just didn't appear suddenly from the sky one day. There was something before Ethernet that played a very large role for the success of Ethernet, and this technology is called packet switching. Packet switching created these basis for success for Ethernet. Packet switching means created the paradigm switch between the monopoly on telephone networks on resources to resource sharing. So what does resource sharing mean? You may have heard that term a lot. This is a map of Korea's highways, and from everyone here, if you are very young, I think you may not understand what a LAN cable telephone is. So I want to explain this as simply as possible. So you're trying to go to Busan to Seoul, and you want to use the first lane. So before the telephone lanes, they had a monopoly over that first lane, and only you could use that road. So that was the previously existing telephone networks. But there are many different lanes, so you can use the second lane or the third lane based on which part of the region you are. In the past, only one person had a monopoly over that lane. So the federal government of the United States realized that this is very inefficient. So when people try to make a call, they want to have two people. So if two people are making a call, if one person is talking, the other person is listening. So the efficiency rate is only 50% unless both people are talking at the same time. So usually when people talk, you speak and breathe and speak and pause, and that pause can be quite long. So if you think about it, the actual efficiency of the currently existing telephone lanes were not very efficient. So instead of that, if you think about how cars can freely drive on the roads, now the United States came up with the idea of putting the information in packets and then send the packets through communications lanes. So from the 1960s, we started to see the rise of packet switching technologies. So after the winning World War II, there were so many advancements in technology, such as Alan Turing, who played a large role in crypto security. So the United States made a lot of investments in computer networking in computers, and then they realized they want to connect the computers through networking. So at the same time, the United States, Britain and France, they started to do a lot of research in packet switching. So in the UK, Donald Davies created the packet network, and while in France, the packet switching network was created, while in the United States, the message block network was created. And Leonard Kleinlock from the USA is from theory. So especially if you are doing OR in systems engineering, then you would know what his work is. So he applied the queuing theory to packet switching. So these people all made large advancements and played a large role in the development of packet switching. So telephone networks and internet is different. So no longer, the lanes were no longer monopolized by telephone networks. What packets do is there is a switch and router between the connection lines. So the packet is like a unit. It's like a car that takes people. People go in the car and they move forward. So packets are kind of a store and moving forward type of technology. And then, so in a packet, you make sure that everyone in the car that started in the car, you all arrive at the same place. And the traffic is bursty. What this means is, as I briefly said before, if there was a monopoly on the communication line and it was not used 100%, sometimes it was used and it was not used. So that's what it means by bursty. Sometimes there would be a lot of packets that come, but then sometimes there wouldn't be any packets. Just like we talk and then we pause and then we talk and pause. So when audio is digitized, it's also very bursty. So the traffic is very bursty. And in the past, the routings were not in packet units. So in the past, if you were to go to Seoul to Busan, you would call the lane and say, I need to use this lane, so keep the lane empty from such and such a time. And then I would start the car from Seoul, and then it would go all the way to Busan. And then all cars would go the same way. But for routing, the information moves in packets. So while I am making an internet call, all of the packets do not go the same lane. Some packets go through the Guro telephone company. If there's a problem there, then it could use a different communication route. And to make the internet, the core needs to be simple. So if there are too many complicated functions in the routing, then it becomes also too difficult to fix as well. So many of the complicated functions started to be taken out of communication devices. And all of the intelligence would go to the edge. So the core would stay dumb. And the people who made the internet won the award in 2004. It was Winton Cerf and Robert E. Kahn. And they received the award for pioneering work on internet networking, including the design and implementation of the internet's basic communication protocols, TCP/IP, and for inspired leadership in networking. So the basic protocol of internet is TCP and IP. These two are the people who first came up with the idea of TCP and IP and also built the systems. So TCP low, TCP IP, you can use Ethernet or wireless internet. You can also use the cellular network for internet. And all of that is based on the technologies of TCP and IP. So all of the web services, so this is a service, a function that serves all the many functions above it. So in the 60s, there was a lot of research on packet researching. But a lot of issues in packet switching came out as well. In the 1970s, there were so many implementations that were created based on the technologies of packet switching. And there were competition between companies to make the best network. So how did Ethernet survive this competition? It doesn't have a token. So token networks can be very simple, and it's easy to make large networks. But the biggest issue with tokens is the moment the token is gone, the network is also down. So token, basically it means that only the people who have the token can use that network. So if you have the token, then you can send the packets. And then if you don't have to send packets, then you give the token to someone else so that that person can use it. So this is one way to share resources. However, the problem is, let's say the computer that had the token died. Then you don't have the token anymore. And so you need to reset the token from the beginning. And this became very complicated when it came to trying to fix issues in communications. So packet tokening networks were taken over by Ethernet. So going on to Dr. Metcalfe, let's hear how difficult it was for him to get a PhD degree. He registered for the Harvard PhD program in 1969. But his actual research, so his advisor at Harvard seems to be not interested in what he was doing research. So his actual research took place at Project Mac at MIT. So he did work connecting MIT mini computers to ARPANET. And ARPANET, and that project was actually very successful. And later on, he didn't even have his PhD degree yet, but Xerox gave him a job offer because of his work. However, Harvard did not give him a pass for his PhD thesis. So Metcalfe said, I need to take a break. So he went to University of Hawaii. He went there to have fun, or maybe research. It's not quite clear, but he went to University of Hawaii, and there was something called AlohaNet at Hawaii. So Hawaii has 5 large islands, and there was a packet switching technology to connect the 5 islands. And University of Hawaii had created a wireless packet networking system at Hawaii. And Metcalfe studied AlohaNet and realized, wow, this is such a great technology. So he did some research about how to fix some of the bugs that AlohaNet had. And he added that research to his work, and he was able to receive his PhD. But Harvard University did not even print his PhD report. If you look at the title is Packet Communication. Nobody today would be able to write a paper like this with this title, Packet Communication, because it's so generic. But at this time, this was very new. And so after receiving his PhD degree, Metcalfe worked at Xerox. What Xerox did at the time was, when they needed data, they would use Synchronet to get the data. Synchronet is like carrying around a disk in your pocket and then use it. So for example, like it's like a USB. You take data, put the data into the USB, and then you can move it somewhere else. So that's kind of what Synchronet was. But Xerox said, this is not what we want. We want to make a network. So they wanted to create a network that could connect thousands of devices like computers and printers. And Metcalfe was able to do that. His first network implementation was 2.49 megabps. The reason for that is because the system clock of Alto systems was 2.49 hertz. So he used the Manchester coding to create the first network implementation. So the 2.49 megabps is a very surprising speed. Do you remember the modems that we had many years ago? I think it was about 100 kilobeats or several dozen kilobeats. But at the time, in the 1970s, the researchers at Xerox were working with 2.49 Mbps. So the people who were working with them in Silicon Valley were so surprised that data was moving at 2.49 megabps. And then in 1973, the first Ethernet was operated. And even in textbooks, you can find this Ethernet sketch by Dr. Metcalfe. And so the yellow line is called the ether. So sometimes if you, sometimes some of the cable channels that you see on TV, these would come in through the ether cable. So you can see the transceiver and the interface cable and the interface controller, which makes up the Ethernet sketch. And I believe that you will be able to see this in museums in the near future. Then he wrote a paper on Ethernet distributed packet switching for local computer networks. This came out in 1976 and was published in CSCM. So the authors was R.Metcalfe and David Boggs, and David Boggs played a large role in his work, but David Boggs passed away very early. But he played an enormous role in the development of Ethernet. And they call it local computer network. So even at this time, the term local area network didn't exist. What did Metcalfe learn through his work at Alhoanet? Again, token rings, you need to have the token for it to run. For wireless, unlike wireless connections, for wired connections, once you send a signal, you don't know whether the other person is also talking. And so once you send the signal, and then if there isn't a response for a certain amount of time, then you would try sending another signal again. But for wired connections, it is possible to hear who is sending signals. So Ethernet, some of the functions that were added to Ethernet was carrier sensing. And once you send all of your signals, and if you wait for the length of the Ethernet, then you would know that your packet was sent. But before your packet is sent, then if some kind of signal occurs, then you can know that there has been some kind of collision. So Ethernet also started to have a collision detection function. And let's say you send a packet, but it keeps interfering with many other packets that other people sent. Then everyone who was doing wireless networks, what do they like? They like to use the algorithms. And so if there were too many signals, then the transmissions would be suspended for a certain period of time. So I have a simple image to explain to you what happens. So let's say there are several hosts and they all collide. So all the packets, they are colliding. And so what can you do? But you can't know how many packets have collided and who the hosts are. And then what the hosts do is that if there's a collision, then they randomly back off. And the backing off is really random. And of course, even after the random back off, they could have another collision. So if that happens, then the signals will back off again. And I believe that in computing, back off is a very often used concept. So this concept of backing off was implemented very efficiently into Ethernet technology. So the Ethernet technology became something that became very easy to use. So this technology is used not only for Ethernet but also for Wi-Fi as well. So for example, if you make a call and if the signal is too slow, then it would back off. So you can type random back off on the internet. You can find many relevant or irrelevant data on there. So in 1983, Ethernet was standardized as IEEE, and in the beginning it was only used in local area networks. But now it's also being used in metropolitan area networks and wide area networks. And now there are even different Ethernets for companies, such as an Ethernet for Google and an Ethernet that Microsoft uses. So what did Dr. R.Metcalfe do afterwards? He created a company called 3Com after leaving Xerox in 1979. 3Com went public in 1984. Its sales profits reached 5.7 billion USD in 1999, and then it was acquired by HP in 2010. He won the IEEE Medal of Honor in 1996 and won the Marconi Award in 2003. In 2007, he was inducted into the National Inventors Hall of Fame. From 2011, he served as a professor at the University of Texas in Austin. Currently, he is a research professor at MIT, and he gave his Turing Award acceptance speech at the 2023 Web Conference. So if you want to watch his acceptance speech, you can find it online. So Professor Dr. Metcalfe,
2007년에 National Inventors Hall of Fame이 있는데
so there's a National Inventors Hall of Fame, but there's also something called the Internet Hall of Fame. So before that, I want to explain the enormous growth of the Internet. So based on the technologies, so Ethernet won in the competition of all the technologies that were created in the 1970s. In the 1980s, France made something called Minitel and gave it out to all of its citizens. This is based on packet technology. And in the 90s, when I was doing my master's and PhDs, there were many different networks such as ISDN, BISDN, and ATM. So these were all competitors of Ethernet. Then in the 90s, NSFnet became private, and BitNet and CSNet all became integrated into one. So these were all working separately. But now those became inter-networked. And there were companies who would use their own networks in the world. So if you met people in the IBMs in the 90s, and they would use their own network to communicate. But all of those proprietary networks disappeared, and the web browser was created in the 1990s. And there was an enormous growth of internet since then. So after the privatization of NSFnet, people thought, how do we use this system? So the web browser was created, and Dr. Tim Berners-Lee won the Turing Award for his work in developing the internet. So before we go, I want to share this. This is the Internet Hall of Fame for 2012. And so I wanted to point out some of the people. So you also find Al Gore, who was the vice president during the Clinton era. And there is also Tim Berners, who won the Turing Award. There are the people who made Linux here as well. And Louis Pouzin, Leonard Kleinrock, and Paul Baran are the people who created the idea of packet switching. And then we have Donald Davis from the United States, and people like Robert Kahn, Vint Cerf, who have won the Turing Awards for their work. And there is someone from KAIST in this Hall of Fame. Do you know who it is? It is Professor Jeon Gil Lam. And
두번 받은 셈인데.
So
Vint Cerf
and Robert Kahn, Tim Berners-Lee,
HTTP 프로토콜 만드셔서 했다 했을 때
these people already won the Turing Award. So then who would be the next person to win the Turing Award? I think it will be Van Jacobson, because he is the one who made the communications for the newest technology, so I believe he is a strong contender for the next Turing Award. And I would like to end my presentation here. Thank you.